All right, as we are moving on to topic 4 in our inequalities unit, you're going to open up to your green divider in your notebook and you're going to fill in topic 4, which is solve two-step inequalities. So if we're moving on from one-step to two-step inequalities, it will be very similar to solving two-step equations. So make sure you have this written in your divider before you go on. So next you're going to open up to the next page in your notebook and you're going to glue in your notes page for solving two-step inequalities across from the notes page where we learned when we are going to need to flip your inequality sign. And you're going to, while the paper is sideways and your notebook is right side up, you're going to write up at the top, you're going to write the title that we put in our divider, which is IN4 for inequalities topic 4, solve two-step inequalities. And so you can write this either on the paper, the notes page that's been cut out, or above it in your notebook, wherever you have more space. So your title, Inequalities topic 4, solve two-step inequalities. Then once you have done that, you're going to turn your notebook now sideways so that your paper that's glued in is right side up. And we're going to start in the top left here. I have 9b plus 3 is less than -6. So in this first box, I'm going to solve this inequality using the boo-boo method. Down here, before we graph it, I will also solve this using the do and undo method. As I know some people are more comfortable with that method, I do want you to have both versions of it in your notes. So solving using the boo-boo method first, we would start by drawing our railroad tracks below our inequality sign instead of below our equal sign, below our inequality sign, and we'd start by boxing in our variable and what's with it. So it's this entire term right here, the 9b. Just like when we use the boo-boo method for equations, the first b and the first boo of that method is to box in the variable and what's with it. It's not until you get rid of other stuff that you only box in the variable. So I want to get rid of whatever is on the same side of the inequality as my variable that's not boxed in. So I want to get rid of the plus 3. So I'm going to subtract 3 and I'm going to do it on the other side as well. The plus 3 and minus 3 would end up canceling. So I would carry down the 9b to the next line, and -6 minus 3 would give me -9. And you are welcome to use Desmos for any of this. For this, I'm just doing this in my head using integer operations, but you are welcome to use Desmos for any of the steps along the way. It's the only thing that you can't do is you can't just type in the whole thing and expect Desmos to give you the answer like we were able to do with replacement value. You can do that when you do your check because that's essentially using replacement value. But to get to that point, to solve it to begin with, you just have to go step by step. So I have 9b, I have -9. I did not have any negative coefficients or negative denominators that caused me to divide or multiply by a negative. So I can just carry down my inequality symbol. So I have 9b is less than -9. At this point, I'm going to go through the boo method again. So I'm going to box in just the variable this time. And then I want to get rid of the 9 that's being multiplied by it. So instead of multiplying, the opposite operation would be division. So I'm going to divide by 9. Extend my railroad tracks here. Divide by 9. This will cancel on the left side. which will just leave me with b to carry down. And again, I divided, but it was not by a negative number because I didn't have a negative coefficient to start with. So I can just carry down my inequality sign. And negative 9 divided by a positive 9 would be a negative 1. So I end up with b is less than negative 1. Now I want to keep it this way, especially before I graph, but again, sometimes your answer choices could be written another way. So you have to understand how to switch your inequality around, even if it's switching it so the variable is on the right instead. So another way to write that would be if I were to switch the entire inequality around and put the negative 1 on the left and the b on the right, my alligator, remember, still has to chomp the bigger number. Still has to eat the same diet. So when I put negative 1 on the left side, the alligator still has to chomp the negative 1. So my inequality sign does turn around when I rewrite it the other direction. So negative 1 is greater than b. So if b is less than negative 1, that means that negative 1 has to be greater than b. Now, for those of you that prefer the do and undo method, I want everybody to take this in your notes. So again, so you have it. You may decide as we go through this more that you do prefer one method over the other, and that is completely fine. But for your notes, I want you to have both methods down. So I'm going to start by drawing my t-table. And my variable that goes on the left is the b that's up at the top there. So I'll slide this down so you can see the b is up at the top. I'm not going to go ahead and write my equal sign like, or my inequality symbol like I did with my equal sign, because sometimes you do end up having to switch your inequality sign around. So I'm not going to do that till the very end. If I follow order of operations, the way everything was listed on the left-hand side here, I have both multiplication and I have addition. The first thing that would happen is that the b would be multiplied by 9. So I'm going to write times 9 on the left-hand side. Once I multiplied b times 9, I would add 3 to it. So that's on my do side. Down at the bottom, I write what's on the other side of the inequality, which is negative 6. Then I can undo it by doing the opposite operation. So the opposite of plus 3 is minus 3. So I'm going to do this as I do the undo side here. So negative 6 minus 3 would give me negative 9. It's becoming more negative. And then the opposite of times 9 is divide by 9. So I take that negative 9 that I got, divide that by 9, and I would get negative 1, just like I did up here. I'm not putting equals 1 because it's not equal to 1, but I'm going to put negative 1 up at the top here on the right, and then I would just have to fill in my inequality symbol. So again, since I did not have any negative coefficients or negative denominators that caused me to divide or multiply by a negative number, I subtracted here and I multiplied by a positive 9 and I divided by a positive 9. There was no division or multiplication of a negative number. I can rewrite my original inequality sign, which is less than. So I can get b is less than negative 1. Again, you want to make sure that you can write it both ways. So another way to write that would be negative 1 is greater than b. So I'm just writing it in both fashions here with both of the ways I can solve it. Now we want to come up with some possible solutions. So I just want to list 3 of them. Really there would be an infinite number of solutions, but I need, if I'm trying to find a possible value for b, I need a number that's less than negative 1. So that could be something like negative 2. It could be something bigger, well, not bigger, but farther to the left, like negative 21. Or it could be a decimal like negative 1.5. It would be a little bit smaller than negative 1 because it would be a little bit farther left on the number line. Next, I need to figure out when I graph this, which version, I want to rewrite my inequality, but I just want to make sure that when I write it, the variable's on the left. So I did come up with 2 ways I could write it. I'm going to rewrite the version where it says b is less than negative 1. I know that I'm going to put my whatever I'm comparing to my variable, so the -1 in the middle of my number line. To the left would be -2, and to the right would be 0. Now when I graph this, I have to make sure I know which type of circle I'm going to use. So this does not have a line under my inequality sign, so it would be an open circle. And so then I will draw the open circle on -1. And because I have this written with my variable on the left-hand side, I can use that inequality sign to draw my arrow to show me which way to shade in my number line. So I'm going to shade to the left. And as it makes sense, these values are to the left. These values to the left are less than -1. In fact, -2 was one of the possible solutions that we came up with. Now I want to make sure to check this. Especially these two-step inequalities, you could end up flipping your sign around if you divide or multiply by a negative. Some of these you'll see your variables on the right-hand side and you have to make sure you graph that correctly. So the check is super important, but it doesn't have to take very long. I'm going to rewrite my original inequality, which was 9b plus 3 is less than -6. Now when I'm checking this, I'm just checking the side that has like math I can do. Can't do anything with a -6, it's all by itself. But what I want to do is pick one of our values we came up with as a solution and plug it in for the place of b. For example, if I picked -2, I could say 9 times -2, then plus 3 has to be less than -6. So again, I'm just plugging this part, and you can use Desmos and just plug it in. I am putting that part into Desmos. So I'll pull that up. And I can just put in 9 times -2 plus 3, and that gives me -15. So -15, as long as that is less than -6, is -15 less than -6? It is, so it checks. I'm not going to come up with the same number on both sides. It just has to be a true statement. So moving on to the next question. First of all, you have to notice here that my variable is on the right-hand side, and I'm also subtracting my variable. So I'm going to draw my railroad tracks, but when I go to box in my variable and what's with it, I'm not just boxing in the 10 and the a. When I'm subtracting the variable, that's the same as adding a -10a. So I'm going to box in this right here and then like squeeze a little plus on in here. This is 3 plus -10a. So that's important, or you're going to end up undoing things, doing the wrong operations to try and solve for your variable. So my variable's on the right. I'm not trying to get rid of the -97 because that's not with my variable. I'm trying to get rid of the 3. So in order to get rid of the 3, I need to do the opposite operation. Again, that 3 is being added to the -10a. So the opposite of adding would be subtracting. So I want to subtract 3 from both sides. So that plus 3 and minus 3 will cancel. On the left-hand side, if I have -97 and I take 3 more away, that would be -100. And I would carry down my -10a. At this point, I have not multiplied or divided by any negatives, so I can carry down my inequality sign. Now, when I look at things here, I have to be careful. I do see that I have a negative coefficient, and I actually had one up here. It was harder to see the way that it was written. But I didn't multiply or divide by a negative. I didn't multiply or divide at all. So it really didn't affect that first line. But now I have a negative 10a. So I'm going to highlight that negative 10 because that's my negative coefficient. So I know that in the process of solving this, I'm going to end up having to divide by that negative 10. If I divide by a negative, I'll have to flip my inequality sign. So I've highlighted it so I don't forget that. So I'm going to extend my railroad tracks a little bit. And I'm going to divide by negative 10. Oh, I'd box in my variable for that step. Divide by negative 10. And divide by negative 10 on the other side. So on the right-hand side, my negative 10, or times negative 10, it was being multiplied by the variable, divided by negative 10 would cancel. So I would just be left with my a on this side. And on the left-hand side, negative 100 divided by negative 10, well, a negative divided by a negative would be a positive. So I can just think of it as 100 divided by 10, which I know is 10. Now here's the tricky part. I know that when I highlighted that negative coefficient, that I was going to have to switch my inequality sign around. So instead of just carrying it down, I am going to flip it. So instead of being a less than sign, it is now a greater than sign. So I have 10 is greater than a, and I'm going to highlight where I switched it, just kind of as a way of checking that I knew I had to flip it, and here's where I did. Now, I want to make sure I know how to write this the other way. In fact, when I do graph, I wouldn't want it like this. This is a correct answer. It's not wrong. But you need to make sure how to write it with the variable on the other side as well. So if I were to write it with my variable on the left and the 10 on the right, again, my alligator still has to trump the 10, so it would, my inequality sign would have to turn around in order for that to happen. So when I graph it, I will use a as less than 10. All right, going down to our do and undo method. This is going to get a little bit complicated with your variable on the right-hand side, so keep up with me. I'm going to start by drawing my t-table. Instead of putting my a on the left, because it was on the right side of the inequality, I'm going to put it on the right side of my t-table. Again, I'm not going to write my inequality sign yet because things could end up switching around. Following order of operations, again, you still have to be careful with this one, and remember, rewriting anytime you're subtracting the variable, writing it as addition will help you with this. Following order of operations, the first thing that happens to the a is not that it gets multiplied by 10, but it gets multiplied by a negative 10. So I'm going to, this time, have my do side on the same side as the variable, so I'm putting it on the right side, and I will have my undo side on the left. So the first thing that happens to the variable is it gets multiplied by negative 10, and then, again, this is addition going on here, I would add 3. And down at the bottom would be the negative 97 that's on the other side. So negative 97. Now again, I'm going to undo things. I'm just on the other side. So I would subtract 3 because that is the opposite of adding 3. So negative 97 minus 3 would still be a negative 100, which is what we got when we solved it using the boo-boo method. Then I would divide by negative 10 because that would be the opposite of multiplying by negative 10. So I take that negative 100, I divide it by negative 10, and I would still get a positive 10, and I will write it up here just like I did using my other method. Now here's where you have to be careful. This was my do side, this was my undo side. Because I was multiplying by negative 10 to start with, I ended up having to divide by negative 10, which meant I had to switch my inequality sign. So originally it was less than, I will switch it so that it's greater than. So this and this are the same. I want to make sure I can write this the other direction with my variable on the left. So another way to write that would be a is less than 10. So I can come up with both ways of writing it no matter which method I use to solve it. All right, so some possible solutions here. I'm looking for, and I like to again use the version that has the variable on the left to help me come up with solutions. It's just easier for my brain to process. If a is less than 10, I want a number that's less than 10. So you could use 9. You could use 8. You could use -1. Any negative numbers, of course, would be less than 10. Or you could use 0. Anything that's less than 10. I could not write 10 because that's not less than itself. So now I'm going to graph it. So I'm going to use the version that had the variable on the left. So I'm going to use a is less than 10. And I'm going to write 10 in the middle of my number line. So I'd have 9 to the left, 11 to the right. And again, since I do not have a line under my inequality sign, this would be an open circle. So I'll draw an open circle on 10. And with my variable on the left, I can use the inequality sign to help me figure out which way I'm shading. I'm shading to the left. And again, 9 was one of the solutions that we listed. Anything where there's shading is a possible solution. That's why we don't shade in. That's why we don't shade in the 10 if it did not have an or equal to sign, because there would not be shading there because it's not a possible solution. 10 is not less than itself. All right, so to do the check, I'm going to rewrite my original inequality. Now, even though this one did have, I'm moving the camera a bunch, but it did have me subtracting the variable, I'm not going to rewrite it with addition or anything like that. Just in case I made a mistake, I want to make sure I just write it the original way. So if I made any mistake along the way, I'll catch it. So -97 is less than 3 minus 10a. That was my original inequality before I changed anything. And I will do 8 here. I will substitute 8 in the place of a. So -97 has to be less than 3 minus 10 times 8. And you could work through this and do this step by step, following order of operations, but again, you don't have to take that much time because you can just use Desmos. I'm not doing any calculations on the left-hand side here. There's nothing to work out, it's just -97. But what I am going to do is figure out what all this is equal to. So this is where you can just pull up your calculator. And you can type in what's on that right-hand side there. So 3 minus 10 times 8 gives me -77. So I'm going to write that down here. -77. So as long as, my full screen again. As long as -97 is less than -77, then this checks. And -97 is farther to the left on the number line than -77. So it does check. We did everything right along the way. Even though there was multiple times, really, I switched my inequality before graphing it. I switched my sign around before graphing it. We did everything correct throughout that process. The only thing you don't want to do when you check it is, if you had an or equal to, you don't want to use that number that it's equal to check it, because that just won't help you decide if you shaded in the correct direction. But we didn't have that as an option here. All right, on to our third one here, and this one has a fraction as a coefficient. That's okay, don't let it freak you out, but we're going to follow the same steps that we've done for the other examples. So using the boo-boo method, I'm going to start by drawing my railroad tracks. And I'm going to box in the variable and what's with it. So in this case, that's the 1/3 v. My coefficient with my variable, they're the same term. I box them in together. So what I want to get rid of is that -7 that's on the same side of my inequality as my variable, but that's not boxed in. So the operation that's currently happening is addition. The -7 is being added to the 1/3 v. So the opposite operation would be to subtract -7. And I would do the same thing on the other side. Subtract -7. So on the left-hand side, the plus -7 minus -7 would cancel out. I would end up carrying down that 1/3 v. And -9 minus -7. You can type it in Desmos just like that, but I'm going to recognize that subtracting a negative is the same as adding. So this is the same as saying -9 plus 7. -9 plus 7 would be a -2. I did not have a negative coefficient or negative denominator. In fact, I didn't divide or multiply in that first step, so I can just carry down my inequality sign. So I have 1/3 v is less than -2. So at this point, I will go ahead and box in my variable, and I want to get rid of the 1/3. Well, that 1/3, since it's the coefficient, is being multiplied by the v. So the opposite of multiplying by 1/3 would be to divide by 1/3. So I would divide by 1/3 on both sides and extend my railroad tracks. So times 1/3 divide by 1/3 cancels over here. And I would just carry down the v. Now this is where you probably want your calculator. I have -2 divide by 1/3. We have talked about some in class how if you take the inverse operation with the multiplicative inverse, that would be the same. So I could multiply by 3 and it would be the same as dividing by 1/3. But we're still kind of new at that, and we're a little more comfortable with Desmos. So I'm going to pull that up and show you how you can still calculate that in here. So I would type in -2, divide by, and then I want to use my fraction button over here to put in the 1/3. There we go. And we would end up with -6. So you can see that dividing by 1/3 would have been the same as multiplying by 3, because -2 times 3 would have also given me -6. So I'm going to write my -6 over here. All right, and I did not end up multiplying or dividing by a negative. This was not a negative coefficient to start with, so I can just go ahead and carry this down. So I have v is less than -6. Again, you do want to make sure you know how to write that with the variable on the other side in case it's necessary, even though this is how I would graph it. You may have to identify it written the other way. So another way to write that would be -6 is greater than v. So v is less than -6, or -6 is greater than v. All right, and we are going to go on to solving this using the do and undo method. So I'm going to start by drawing my t-table here. My variable was on the left, so I will put it back on the left-hand side. The first thing that happens to my variable is it was multiplied by 1/3. So you would have times 1/3, and after v is multiplied by 1/3, you add -7. So plus -7. Down at the bottom would be whatever was on the other side of my inequality, so -9. And then I undo things. So the opposite of adding -7 would be subtracting -7. So -9 minus -7, again, that would be the same as adding 7, so -9 plus 7 would give me a -2. The opposite of multiplying by 1/3, dividing by 1/3. So you take the -2, divide by 1/3, and again, you probably would want Desmos to solve this, but we've already solved it up above. -2 divided by 1/3 would be -6. So I would place -6 up here, and then I can go ahead and write in my inequality sign. I didn't have to flip anything around. My variable was already on the left, so I'll just rewrite that original less than sign. So v is less than -6. Again, or you could write it -6 is greater than v. Okay, moving on to some possible solutions. So I need a number that is less than -6. So remember, when you're dealing with negatives, a number less than -6 would be to the left of it on the number line. So something like -7. You could have -10. Something as far to the left as -42. Okay, as long as it's to the left of it on the number line. I could not list -6 because I did not have that line under it meaning or equal to. And again, I could have used a decimal here like I did in the first one. Could have said -6.1 and it would have been a little bit more negative than the -6. When I graph this, I want to use the version with my variable on the left. So v is less than -6. I'll place -6 in the middle of my number line. -7 would be to the left and -5 to the right. Again, no line under my inequality sign, so it would be an open circle. So I'll go ahead and draw my open circle on -6. And with my variable on the left, I can use my inequality sign to show me which way to shade in, what my arrow would look like. And this one, again, is going to the left. So far, these three that we have done, they've all been open circles shaded to the left. Now, to check this, so I would rewrite my original inequality, which is -7 plus 1/3 v is less than -9. I would have to pick one of my values here that I used, or one of my possible solutions to plug in for the place of v in order to check it. So let's see, I will use -10 this time. So I'll have -7 plus 1/3 of 10 has to be less than -9. And this is where having Desmos in recent years and this year is so helpful because you don't have to go through step-by-step order of operations. I know 1/3 of 10 is not going to work out nicely, but it really doesn't matter what Desmos is going to do all that for me. So anything that's kind of separate from just that -9 is what I'm putting into Desmos. So I will clear this out and put in that -7 plus 1/3. You can do 1 divided by 3 or you can use the fraction key. You just have to make sure you click out of the fraction afterwards. Times 10, so you could use the times symbol or you can use parentheses like I'm using. And that's all I have to solve for, which gives me -3.6 repeating. Oh, you know what I just realized? I did not put a negative in there. -10. There we go. That works out. I have to put my negative in here. Otherwise, it would not check. If you use positive 10, it would not work. Okay, so that gives me -10.3 repeating. And as long as that is less than -9, meaning farther to the left on the number line, then that does check. When I accidentally left off that negative, it actually gave me -3.6 repeating, which would not have been less than that. So that would have been a red flag. I did something wrong. In that case, what I did wrong was in my check rather than solving the problem. So be careful about that. And we are moving on to our last problem here. And this one has a fraction. So we did struggle a little bit with solving equations, two-step equations with fractions. So I want to make sure that we are pretty solid with this with our inequalities. What I have to remember when I'm trying to figure out like which order to undo my operations in, I have to remember to insert parentheses around my numerator here. I could put them around my denominator as well, but there's only one number there. I need to put parentheses around my numerator because that shows me that what is in the numerator is grouped together. So when I draw my railroad tracks and box in my variable and what's with it, I'm not trying to box in like the R and the 22. They're not next to each other. The R and the 5 are grouped together in the numerator, so I'm going to box this in, the entire numerator. Now I'm going to want to get rid of that divide by 22. I'm not getting rid of the 1, even though it's on the left-hand side. It's not the same side as my variable. So I want to get rid of that divide by 22. So the opposite of dividing by 22 would be multiplying by 22. And so I would do that on both sides. On this side, things would cancel, and I would carry down the R plus 5. And over here, 1 times 22 would give me 22. I did multiply here, but it was not by a negative number, so I can carry down my inequality sign, which was my less than or equal to sign. So now I have a one-step inequality. I will box in just my variable, extend my railroad tracks here. I want to get the R by itself, so I want to get rid of the plus 5. The opposite of adding 5 would be subtracting 5. So I will subtract 5 on both sides. This over here would cancel, so I would carry down just my R, and 22 minus 5 would give me 17. Again, I just subtracted 5. I did not multiply or divide by negative, so carry down your inequality sign. So I carry down my less than or equal to. So here's my answer. 17 is less than or equal to R. Again, I have to make sure I know how to rewrite that. So, or that would be the same as R is greater than or equal to 17. Both answers are correct. You have to understand how to convert one to the other, and you would want it with your variable on the left when you graph it. Now taking this and converting it to my my do and undo method. I'm going to draw my t-table here. My variable is on the right again, so I'm going to put my variable on the right of my t-table. Again, I'm not going to write my inequality sign yet. The first thing that happens to my variable, again with grouping, solving order of operations here, grouping is first. So a lot of times you do multiply or divide first because that normally comes before addition or subtraction. But in this case, this is grouping, so this comes first. So the first thing that happens to the R is that I add 5 to it. After I add 5 to it, I would divide it by 22 because that's in the denominator. Again, since my variable's on the right-hand side, I'm listing my do side on the same side as my variable and coming up on the other side. What goes down at the bottom would be the 1, because on the other side of the inequality. Now I can undo things. So the opposite of dividing by 22 would be multiplying by 22. So 1 times 22 gives me 22. The opposite of adding 5 would be subtracting 5. So 22 minus 5 gives me the 17. So again, I'm not writing equal 17. I'm putting the 17 on the left-hand side. And since I did multiply to undo things here, but it was not a negative number, I just rewrite that inequality the way it was originally. So 17 is less than or equal to R. Now, you do have to be able to write it the other way. So R is greater than or equal to 17. So possible solutions. I like to, just like graphing, when I come up with possible solutions, I like to have the variable on the left. It's easier for my brain to say blank is greater than or equal to 17, or what number is greater than or equal to 17, instead of saying, well, 17 is less than or equal to what number. It's a little bit harder for me to work with. First of all, I do know that 17 is a solution in this case because it does have the line under it, meaning or equal to, so 17 works. But I also want numbers that are greater than 17. So you could have 20, you could have 25, could have 100 as long as it's greater than 17. Alright, so now I'm going to graph it. So again, when I graph it, I'm going to use the version with my variable on the left. So r is greater than or equal to 17. 17 will go in the middle, 16 on the left, 18 on the right. Now, for the first time, I actually have a line under my inequality sign, so this will be a closed circle. So I'll draw a closed circle on 17. And the way it's written with my variable on the left shows me how I can draw my arrow. This time I'm going to the right. So I will shade in values to the right. Now, when I check this, I do not want to use 17 because even if I've shaded this in the wrong direction, since 17 is shaded in, my circle is shaded in, my check would check even if I shaded in my arrow the wrong direction, because 17 would be a solution no matter which way my arrow was facing because it's shaded in for my circle. So the only thing is you just don't want to use 17 to check it, but you can use any other number that you come up with as a solution. So I'm going to rewrite the original inequality, which is 1 is less than or equal to r plus 5 over 22. And let's substitute in 25. We'll see what happens. It might be an ugly decimal, but we have Desmos. So I will say 1 is less than or equal to 25 in the place of r plus 5 over 22. So this side over here is all I have to put into Desmos because, again, there's nothing to calculate over here. So 1 has to be less than or equal to, let's see what that would wind up being. So we have, remember to use your parentheses for your numerator. I didn't write them here in parentheses, but in order for it to go into Desmos properly, you would need those. So 25 plus 5, close your parentheses, divide by 20. Oops, I did not hit that division key when I thought I did. Divide by 22. Okay, it does give you this repeating decimal. It gives you 1.36, and it looks like the 3 and the 6 keep repeating. Looks like the 4 is rounded up at the end just because your calculator rounds the last digit if it needs to. So it looks like both the 3 and the 6 repeat. So as long as 1 is less than 1.36 repeating, which it is, then this checks as well. And I've solved everything correctly.